You got the recording on?
Yeah.
Okay. Okay, so let's go to blank pages. All right. All right, thank you. And you know, I meant to mention something about the time change yesterday before we left class, and I totally forgot because I was, I had my mind on surveying and that was it. So when I got home, I looked at my calendar, and of course your phone takes care of it automatically, but even though every other clock in the house doesn't, And I still use my phone is my alarm clock, so I was covered, So I was here at 8:30 and waiting for everybody. Then I was like, oh, I forgot to tell them about the time change, and then I heard about the key. So, anyways, we're here. We're almost as excited as we were yesterday, right? And we had some time to do some homework. Maybe get caught up in the hallway there. We did a little more homework. Yesterday we talked about some interesting things. We talked about measurements, error theory, taping, leveling, coordinates, bearings, and traverse calculations. And our focus yesterday was how to establish horizontal and vertical control. And I mentioned earlier on that something sounds weird. What is it? It's the speakers. Is there feedback coming in or something? It's fuzzy, yeah. Right. Let me turn it up a little bit. Is that better or is that worse? Down more then. Okay, how about that? Better? I think that's better. Okay. Remember, when we define engineering surveying, there are two types of surveys that we can do, topographic and construction. And before we could do either one of those, we needed to establish vertical and horizontal control. That's the first thing you did, and that's what we learned about yesterday. Today we're going to learn about how to do a topographic survey in a couple of different ways. We're going to learn how to do it using conventional survey methods, and we're also going to learn how to do it using photogrammetry. After that, we'll be talking about GPS, and that's another way to establish horizontal control. We'll also talk about GIS. What's GIS stand for? I know you guys use it. Geographical Information System, exactly. The hot topic today and the big thing today is to spatially reference information. And that's what GIS does. It can take a variety of information, an infinite amount of information, and tie that to a land base. And I'll talk a little bit about that today as well. And then we'll end up the day with vertical curves and horizontal curves. We'll begin this morning going over the homework problems that were assigned for last night. And those were located in both chapters 17 and 18. We're going to do the ones in chapter 18 first because those are the easier ones. And as I said yesterday, these are not like the ones you're going to see on the exam. They're a lot easier. And the purpose of these is to make sure you have a firm understanding of kind of the basics of surveying, okay? So let's turn to page 322. And those are the problems, and we're going to work these together. Well, let's all turn our phones off before we get started. I'm going to turn mine off now. We'll put it on stun. Airplane mode. Okay, I'm good. The solutions for these problems are also in your manual as well. That begins on page 328. So what I'm going to do is I'm going to put the solutions up here on the overhead, and we'll follow along with this. So the solutions begin again on page 328. So the first problem for homework was out of Chapter 2 of the Surveying with Construction Applications. Did anybody end up getting that book or already have that book? Oh, you already had it. Okay, and you had it too as well? Okay. Yeah, it hasn't changed that much over the years. I think I've got the 4th edition. I think they're up to about the 6th or 7th now. Which edition do you guys have? 6? Okay, I think that's the latest actually. Yeah. Yeah, they put a lot more in there. It's a good book. I probably should get the latest copy myself. Okay, the first problem says a 100-foot add tape was used to measure a parcel baseline distance. The rear surveyor held 47 and the head surveyor held 0.59. Remember that an add tape, only the first foot is fully graduated in hundredths of a foot. So every hundredth of a foot it has a tick mark. And then the rest of the tape or chain is graduated in every foot. Okay, so what happens is, yes. So what happens is 2 people read the tape. So the head chainman reads the hundredths, and the rear chainman will read the foot part. So sometimes when you're measuring something and you have one person on each end, you say, okay, I think we're pretty close. But if it's something near like a hundredth of a foot on my end, or like near 99 hundredths on my end, you might hear the chainman say, give me a foot. What that means is you got to go to the next foot because it's not falling in that 1 foot that I have. Okay, you follow that? Okay, so real simple. All you have to do is add the 2 together. That's it. Have one reading on one end, one reading on the other. You add the 2 together and it's done, just as we say here. So the head guy had 47 feet, the rear guy had 5,900, so we add the 2 together.
Yeah, what I noticed, I looked up a picture of it. It's got an extra foot. So it really starts from 1, graduated down to 0. Then it continues. So when the guy's reading 0.59, he's 0.59 beyond 0.
Yeah, it's 0.59 of a foot. Yeah, so that'll go from 0 to 1, and then the next graduation is 2. Yeah. Yeah, they have a picture of it, I think, in the Kavanaugh book, right? Is that where you saw it? You just looked it up online? Yeah. Good old Google, right? Okay, the next one is let's see, what was the next one here? Number 16 from Chapter 2 in the Kavanaugh book. Compute the corrected horizontal distance. Remember I mentioned yesterday, the first thing you want to do is to correct for temperature. And what is this number here again? The 0.5065? What is that number, though? Where does it come from? It's the coefficient of expansion for in-bar steel. That's where that number comes from, okay? So let's make a note of that. Okay, then we're going to take the temperature of the air minus the temperature of the standardized temperature times the length. Okay, so when we do that, we come up with a negative 200ths. So the next step would be to correct the slope distance, corrected for temperature. So we minus that 200ths, and then we're going to calculate the horizontal distance because we know what the slope angle is. Or what's another word for slope angle? Vertical angle, right? Vertical angle, yeah. So we're going to take the cosine of the vertical angle times the corrected slope distance, and then we can end up with a horizontal distance of 273.77. 273.66. Where did I get 77 from? Okay, the next one is similar. Number 18 from the Kavanaugh book. Compute the corrected horizontal distance. Temperature is 93 degrees. Tape length 100.02. What should the tape length be? 100. Remember, that's one of the things that we could correct for is incorrect tape length. And this one here, it has that. So we take a look at that. So we have three things to correct for. The first, remember, we're always going to do temperature first. So the temperature is plus 1300. That's a significant amount, right? 1300ths of a foot. That's a pretty big correction. But you can see the temperature correction is pretty big there. It's almost 30 degrees, 25 degrees to be exact. And the corrected for length, we have the 200ths times 8.1. Where did this number come from here, this 8.1? Yeah, it's tape lengths, basically. It's 8.137 foot lengths. That's what that is, okay? And we know that every time we do that, we're going to be 200 short, okay? Because when the tape is longer, it's just like it's hot, right? Because it's reading 100.02. That means it's just like it's hot, so it's going to be an add correction. And then the last one is we're correcting for, we have the difference in elevation. So we correct for length and temperature. And then we have a total correction for the corrected slope distance. And then we're going to use the Pythagorean theorem, because we know what the elevation difference and we know what the slope measurement is, the corrected slope measurement. So the horizontal distance, 814 feet. All right, the next one is, let's go back. Let me go back. This one, we're reading a rod. So when you look through the level, it's going to look like this. And we're going to read the center hair, okay? And so in other words, we're going to be looking through the instrument. And we're going to read right there, okay? Now, I'm going to blow this up a lot so you can see the detail of this. Now, you see the really big numbers, the big number 1 and the big number 2. On the real rod, those numbers are